Share screen. Okay, so we continue with the different processes of vapor. Okay? So, sabi ko nga, we have the isometric, pag constant volume yung process natin. And when it comes to constant pressure, isobaric. Sa constant temperature, the isothermal. And we have also the entropy. Tinatawag natin, the change in entropy is always equal to 0 because the entropy at point 1 is equal to the entropy at point 2. Okay? We have also the adiabatic and the polytropic processes. So, pahapyawan lang natin class today is the throttling process. So, ito class, magagamit natin tong throttling process pag sa different cycles natin. Okay? Papasok to doon. So, what is the process of a throttling process? Okay, on a PV diagram. Yan. So, may klase-class yung iba. On the TS and the HS plane. So, kung sa isometric, isobaric, we often use the PV and the TS diagram. Here, we use the molar chart. Okay? So, pahapyawan lang natin. We have the PV. Ayan. I mean the TS. Kakasabi ko pala. Okay, sa TS class, ganito lang. You have this process. Pasmado ang kamot ni Madam. And the HS, we have the HS diagram. We have this, the HS. Okay. Wala pa yun. Anyways. So, in a throttling process class, the given sa atin in a TS diagram, iba yung given temperature natin. Okay? Sa TS, automatically ganito yung pressure mo. Yan. Given sa atin dalawang state points. Galasan, andito yan. Sa wet region at to the saturated vapor. So, this is the pressure at point 1, the pressure at point. While in an HS diagram, sa molar chart natin, malaki-laki to class. Yan. In a throttling process, the pressure is like this, slanting. Yan. From point 1 to point 2, yung mixture niya is this. Okay. Point 1 to point 2. So, ang magiging constant dito, class, is yung layo. Point 2. Ang magiging constant, class, is the enthalpy. Okay? We have here the enthalpy of the pressure at point 1 and the pressure at point 2. So, this is the process in a throttling process. So, tuturo ko naman sa inyo, class, kung paano makuha yung throttling process. Okay? So, sa throttling process, class, fully irreversible, steady flow, adiabatic process, wala tayo ditong work done. Okay? Sa throttling process, automatically fully irreversible. Yan, steady flow to class. Steady flow, adiabatic. Sabihin class, adiabatic also, wala din siyang heat produce and no work being done. So this is the throttling process. From the general equation class in the previous equation natin, we all know we have the kinetic energy, we have also the change in Q, and the work done are all zero. Generally, sa throttling process, we have the enthalpy at point 1 is equal to enthalpy at point 2. So, the general equation in a throttling process what is the general equation? From the figure, based from the figure, okay, makukuha natin si unstable internet. Okay? Having problem. So, we have now the H2 equal to H1. So, how do we compute for H1? The H1 is equal to the HF1 plus the quality at point 1, HFG1. Diba? Kasi nasa wet region siya. And we have an approximate equation in a throttling process. And mga approximation lang to class. In finding the H2, we have the Hg plus the Cp, or the specific heat at constant pressure, times the change in temperature. Ano yung change in temperature mo dyan? Where we have the Hg, this is the specific heat, the specific enthalpy, or enthalpy of saturated vapor. Given sa atin yung, at pressure at point 2, or at temperature 2. Yung change in T class dito is hindi naman yung change in temperature, but the degree of superheat. Diba? Alam natin ang pagkuha ng degree of superheat class. Natatandaan? So, how do we compute for the superheat? Kunin mo muna yung saturated temperature at a specific pressure, at a given pressure. After that, just find the difference between the saturated temperature and the given temperature in the problem. Okay? So that is the degree of superheat. Okay, we proceed now. So, sabi ko, kung you can have it by the given temperature minus the saturated temperature at the given pressure. Okay, so that is the specific. And the specific heat at constant pressure, or the specific heat of the steam, the Cp, the specific heat of steam we have now 2 kilojoule per kilogram degree Celsius or Kelvin or Kelvin. So take note that is on how we compute for a throttling process. Okay? So by interpolation, we can solve problem involving this. Okay? One example. Okay, for example, we have a steam calorimeter. A steam calorimeter receives steam from a pipe at 0.1 megapascal and 20 degrees superheat. So for a pipe, steam pressure of 2 megapascal. What is the quality? So madali-dali. We have the quality of steam. Okay, so the solution in this given problem, ano yung gagawin natin, class? Ano yung una yung gagawin? When we have this, given sa atin yung lahat na given, ano lang yung kailangan natin hanapin? Ano yung una yung gagawin when you have this? Sabi ko, you always draw, or you, ano class? Ano yung ginagawa natin? So, first, gawin na muna natin yung TS diagram. We have the TS. Since a problem class is given na sa atin yung degree of superheat and pinapahanap na yung quality, alam na natin kung ano yung i-sketch natin. Kasi stated na sa problem class, We have the TS and the molar chart. The HS. Okay. Given sa atin yung specific pressure at point 1. Ano yung pressure at point 1? Sige nga. Chat nyo nga dyan, class. Ano yung pressure at sa problem? Yan pa si ma'am. Naririnig ba? Mahina internet? Naririnig ba si ma'am?
Yes po, ma'am.
Apo. Okay. So, naglalag ang aking. Hindi gumagalaw dyan. But, since given sa atin class yung pressure at point 1 and point 2, ano yung mga sagot niyo dito? Ayun, umalis yung isa ko. Point 1, point 1, point 1. Yung iba, anong answer nyo? Sige nga, analyze nyo yung problem class. A steam calorimeter receives steam from a pipe at 0.1 megapascal at 20 degrees superheat. For a steam pressure of 2 megapascal, what is the quality of steam? Ano yung sagot nyo? The pressure is 0.1. But take note in the problem, given sa atin is ano class? You have, ayan, nawala talaga yung internet ko. Naka-date ako class dito sa cellphone. Okay, on your sheets class, but take note sa problem given sa atin is a steam pipe at 0.1 megapascal. So, from the figure, i-connect ko lang class sa aking data. Okay, double check class. You have the 0.1 megapascal and the degree of superheat. And the 2 megapascal is pinapahanap sa atin is the quality. Take note, ano yung pressure 1? Ano yung pressure 2? Sige nga, analyze nyo muna. Sige class, para makonect ko tong iPad. Okay, nakabalik na ako class. Mahina yung internet. Okay, so take note class, given sa atin class. So higher temperature, pag higher class yung temperature, this is the 2 megapascal and this is the 0.1 MPa. We have the the higher to. So, in an HS diagram, this is the 2 MPa and this is the 0.1 MPa. Bakit class? Kasi given sa atin yung degree of superheat, then the 0.1 falls, andun yung point natin. So, this is a 0.2. This is also 0.2. Why? Kasi sa 0.1 natin, pinapahanap yung quality of steam. Ayan. 0.1. From 0.1 to 0.2. Okay. So, this is a throttling, in a calorimeter. Given sa atin yung pressure 1 and the pressure at point 2. Okay? So, if we have now the pressure at point 2, 0.1 MPa. That is the pressure at point 2, class, ha? That is the pressure at point 2. Okay. So, the pressure at point 2, and we have the degree of superheat given sa problem is 20 degree. And we have so the pressure at point 1 class is the 2 MPa. And the required is the quality at point 2. Okay? So, we solve now using this specification or the data. So, at pressure 2, which is the 0.1 MPa, hanapin nyo sa steam table nyo, class. Ano yung gagamitin yung table? Ano yung gagamitin yung table? Here. The table, class. What table? Chat nyo nga, class. Ano yung gagamitin nyo? We have at point 2. Ano po, class, yung gagamitin natin? Anong table? Chat nyo nga, class. Table what? Ayan, connect ko lang. Yung laptop. Okay, so you connect now. Connected na siya. So, given sa ating class yung pressure, you go to table. Table 2, anong page? Table 2. Anong page? Page 8. Sigurado? Ay, steam table ko, nag-isip. Okay. Page 8, 0.1 MPa using ruler. Table 2, page 9. 0.1. Page 9, class. Page 9. Double check. That is page 9. Maduling kayo. Mali na yung answer. 0.1. So, ano yung kukunin nating value? If we have the table 2 at page 9, we have now the Hg at point 2. Gagamitin natin, class, is the approximate. Okay? Yung approximation. So, class, yung gagamitin natin. The approximate computation, the Hg, the specific enthalpy of saturated vapor at point 2. Para makuha natin yung H2, kailangan natin yung Hg at point 2 plus the specific heat times the degree of the superheat. So, from table 2, page 9, the Hg is at point 2 is equal to ilan? What's your answer, class? The enthalpy at saturated vapor, class. Using your steam table. Yung iba. So, we have now the... Excuse me. Okay, thank you, class. So, in finding the specific enthalpy at a saturated vapor, we have now 75.5 kilojoule per kilogram. So in finding the enthalpy at point 2, given this condition, you substitute. Given na sa atin lahat, class, ha? Kilojoule plus the 2. Given yung CP natin, ha? Yan, 2 kilojoule. Because the change in degree is just equal to the change in Kelvin, so you can use this, class, times this is the change, we have 20 degree. So, pwede yung degree Celsius, pwede yung degree Kelvin. Okay? Kasi yung change, class, is equal to the change in temperature in Celsius equal to the temperature in Kelvin. Okay? So, compute for the H2. What is now the enthalpy? So, maka-cancel yung Celsius mo. Okay? What is now our okay? So, what is now our answer, class? In H2, compute. Isa pa lang nakapag-compute. 262 2621 2675.5. We have now, excuse me, 2715.5 kilojoule per kilogram. So this is now the enthalpy at point 2. Since this is a throttling process, we have the H1 is equal to H2. Considering that the pressure at point 1 is equal to the 2 megapascal, ano yung una niyong gagawin? Saan kayo pupunta? Table what? Anong table kayo pupunta? Table ano? Table what, class? Yung pressure at point 2. Table. Yan. May page na. Page 12, table 2, page 12. Thank you, class. So, punta kayo sa table 2, page 12. Table 2, page 12. We have now the 2 megapascal. Ayun, sa pinakataas. Ano yung kukunin mo dito? Ano yung kukunin mo? Kasi pinapanap sa atin is the quality at point 1. Okay. Kunin natin si HF1. Kunin natin si HFG at point 1. Kasi general equation for finding the quality at point 1, we have now this one. So, finding the quality at point 1, we need the H1. Alam na natin yung H1 kasi equal lang naman siya sa H2 over the HFG at point 1. So, at 2 megapascal yung HF1 natin. What is HF1? HF1. That is 90 ilan? 908.79 kilojoule per kilogram. The HFG at point 1, that is 1890.7 kilojoule per kilogram. Tama ba si ma'am? Okay. So, in computing for the quality, we compute now the given parameters. H2 natin is 2715. 2715.5. Tama. kilojoule per kilogram minus the HF1, the 908.79 kilojoule per kilogram, and as well as the HFG at 0.1. Ito, 1890.7. What is now our quality? Quality at 0.1. What is the quality? Ang bibilis. 0.5 minus 908.79. 80.7. We have 0.9969556, which is equal to 95.56%. Okay? So this is now your quality at a given throttling process. Okay? So what for a pipe? Okay, what is the quality of steam? So we have now the answer. The quality at 0.1 is 95.56%. Okay? So we proceed now to the very anticipated first power cycle. Okay. Ano to, class? Na power cycle na to. So, actually, class, we have different cycle, but the very essential na dapat malaman natin is the first, we have the ano yung Rankine cycle. This is the power cycle. So we need to know about the simple Rankine. We have the actual and the ideal Rankine cycle. We have also the reheat. Bakit nagkaroon ng reheat cycle? Because of the excess that can be utilized. Or kasi class sa Rankine cycle, we have the basic components, the generator, the boiler, the generator, the boiler, the turbine, the condenser, and the pump. Since yung extracted na steam from the boiler, it will turn out, it will generate electricity sa super high ng pressure niya. Yung steam natin generated, napapagalaw niya yung turbina. After that, the steam will go into the condenser. Okay. So, before going to the condenser, mainit pa siya, class, kaya nagkaroon ng isa pang cycle na reheat kasi sayang ng init bago muna siya papaikutin ulit siya sa steam boiler, babalik muna siya sa steam boiler or sa steam generator natin. And after that, another turbine. Okay? Papasok dito yung high pressure turbine natin and the low pressure turbine. It's the high pressure turbine, HPT. Turbine and the low pressure. Ayan. Ito sa actual Rankine, this is the basic components natin. Pinakauna is yung steam boiler natin for the heat or the fuel. Yung turbine natin. Pangatlo, yung condenser. And yung pang-apat is yung boiler water pump or the pump. Okay? Meron ding actual pa rin to, class, in the ideal reheat cycle. And yung pangatlong power cycle na dapat nating malaman is the regenerative cycle. Okay. Merong actual and ideal din to. Anong mangyayari dito sa regenerative cycle? So, actually class, dito pala sa reheater, ay sa reheat cycle, we have this. We have also yung so-called na reheater. Kaya nga reheat siya. Okay? Sa regenerative naman class, so basic muna tayo para mas maintindihan niyo. We have also the different boiler feed or tinatawag nating closed feed, water pump. Okay? Papasok na dito yon. May closed and an open feed water. Ayan. Wait lang. Napit ko para sigurado. Ayan. Ayan. Papasok dito yung open natin na feed water. Madaming stages to class ha. Sa regenerative, we can have this. Papasok dito yung feed water heater. Pwede siyang closed feed water or open. Ayan. Okay, class. So, yan yung mga elemento. So, may different stages. Pwedeng 3 stages, 2 or more stages, depending upon the capacity of the power plant. And last but not the least, the reheat and the regenerative. Actually, class, dapat without looking at the book, kaya nyo itong masulat yung... Eto, class, this is the combined. May reheater ka na. Excuse me. May reheater ka na dito as well as yung different feed water. Heater natin. Okay, so the closed or the open. Yan. So, this is the basic power cycle class in Thermodynamics. Okay? So, power cycles in class. Why? Because it produces and it generates electricity. Okay? Now, we proceed with the very first power cycle. Okay? The ideal Rankine cycle class. Okay. In an ideal Rankine cycle, ideal muna tayo ha. We proceed now into the, ibahin natin yung, we proceed with the first, the Rankine cycle. You just read books, class. Okay? Kasi direkta na ako dun sa mismong computation. Okay? Cycle or the Rankine cycle. Cycles. Okay, we have the Rankine cycle. We proceed. In a Rankine cycle class, sabi ko nga, ang basic components niya, we have the boiler, that is the first, the second is the turbine, pangatlo is yung condenser natin. Ang condenser class is a heat exchanger as well as yung pump natin. So, cycle siya. You draw the schematic diagram. Okay? Schematic diagram natin of a Rankine cycle. First, we have the boiler. Ang boiler kadalasan class is bilog lang siya. We have the boiler here. Boiler class, the boiler produces steam. So, you have here the heat. Okay? So, babagaan mo siya. Ano ba pag-drawing ng heat? Wala. Hindi marunong. Basta in class. You have here the heat added So, heat produced dito, class. Ang init dyan. So, automatically, heat is added during this process. Heat is added. So, ayan. Connected pa ba ako? So, the heat is added, automatically denoted as QA. Heat is added at the boiler. Then, we have now, after the boiler, class, the steam produced, yung steam dito, galing dito sa boiler, through pipeline, pupunta siya now sa tinatawag nating turbine. Okay? So, this is now your turbine. Ayan. Therefore, electricity is produced. This is now your turbine. Turbine. Okay? Electricity now is generated via the turbine. Yan, class, yung nasa distribution na natin. Okay. In a turbine class, if in boiler, heat added. So, yung steam natin, pumasok dito sa pipeline, papunta dito, and it makes our turbine. Ano, class? Yung turbina natin, gumalaw. Okay. So, may tinatawag ditong work of the turbine. Ayan, turbine work. So, nag-generate ka dito ng napapagalaw mo yung turbina via steam. Okay? So, yung steam natin ang nagpapagalaw ng blades ng turbine. After that turbine is connected to a generator, then electricity now is produced. Okay? This is how the power plants, okay, class, operates. Okay? So, we have now the work of the turbine, electricity generated. After that, the work of the turbine now. So, from the higher pressure, 0.1. Alright. Okay, so this is at 0.1. Heat is added. At 0.2, meron tayong work of the turbine. After that, yung steam class na sobra dito, yung nagpapagalaw ng turbina. After that, magpapass through ulit siya ng pipeline. Tinatawag na tayong papasok na siya dito sa condenser. Ano ang nasa condenser class? That is a heat exchanger. Okay, from 3 to 4. Condenser class, ganito . So, from that, you have now your condenser. Yan. Anong pumapasok dito? We have the cooling water. So, this is H2O in, and this is H2O out. So, mainit na class yung lalabas dyan kasi mainit yung steam natin. Okay? So, this is now your condenser. After that class, sa condenser, makakaproduce ka na ng tinatawag nating condensate. Ipapump ulit siya. Using a pump, after that class, magiging tubig na dito. Yung steam natin, naiintindihan niyo ba? Ayan. So, this is now your pump. And after that, the condensate is feedback or binalik doon sa ating boiler para pakuluin ulit. Okay? So, yung water natin doon . From that, this is the 4. yung pump natin. So what process in the condenser? If we have the heat added on boiler, the turbine, the work of the turbine, in the condenser class, the heat now is rejected. So the heat is rejected. Why? Because yung steam natin na mainit from the turbine, na galing dito, class. Okay, galing sa turbina, papababain mo yung temperature niya. So, heat is now rejected. And after that, you have now the condensate here from 0.3 to 0.4. Ipapump ulit siya papunta doon sa boiler. So, kung kanina yung work natin, meron tayong ginawang work, turbine, this is a positive work. Here naman, class, we have the work of the pump. Ano yung class sa work of the pump? This is positive or negative? Sige nga. If everyone is listening to me. Positive or negative sa pump natin? Okay. So, in a pump class, that is negative. Why? Because the system is the one who works on the substance. While here, class, positive yung work kasi yung mismong substance ang nagpapagalaw ng turbina natin. Or yung steam natin ang nagdadrive ng turbine. Okay? So, walang ginawa yung makina doon. Siya yung nagpagalaw. While here in a pump, ang nagpagalaw na class is yung mismong pump para makapunta yung condensate natin sa boiler. Okay? So, this is the schematic diagram of a Rankine cycle. Okay, we have the boiler, the turbine, the condenser, and the pump. Okay? We proceed now to, excuse me, 3, 4, tama ba ako? Numbering ko. Okay, so if we have the schematic diagram, we have also the Rankine cycle in a PV and a TS diagram. Okay? So, paano yon? Naintindihan na ba to, class, na schematic diagram ng Rankine cycle? Schematic diagram. Can you raise your hand para, if not, of Rankine cycle. Ayan. So, we have the heat added in the boiler. After that, the steam now is at very high pressure. Automatically, makukuha mo na yung, yun na yung mga at super high pressure class. The steam now can drive the turbine. Okay. So, the Rankine cycle class is composed of different processes. Okay? So, pinakita ko na heat added sa boiler, sa turbina work, and we have now the heat rejected in the condenser as well as the negative work at the pump. Okay? So, we proceed with the PV and the TS diagram. Okay, kadalasan class, pinapadraw ko is the TS. So, TS muna tayo. Okay, in the TS diagram class, okay, class, ano mo yung notation natin dito, dapat naalala nyo i-draw nyo dyan sa papel nyo. Para mas maintindihan nyo yung TS diagram natin. Okay, so we have now the TS diagram. Okay. Take note, the first process natin is from boiler to the turbine. Okay. Same yung pressure natin at a higher temperature. So this is now the I-read natin. Para mas and class, dapat sa ulo nyo to. Ganito lang palagi siya, class. Okay. We have now the bakit parang tabingi yung drawing? Ang ruler. Okay? So, dapat pantayan, class. Okay? Take note, you have your ruler. So, mas maganda kung pantay siya. Okay, so at point 1, we have point 2. Mapadako-dako. Okay? So, this is now the process or the TS diagram of the Rankine cycle. Okay. Paano na? Ano na yung gagawin natin? Ano yung una mong gagawin natin? Okay. Ayusin lang ni ma'am yung numbering natin para mas ma-visualize niya. Okay. Laki. Okay. Ayusin ni ma'am. Para hindi kayo magulo. Okay. First class, yung pinakauna natin in a TS diagram. So, from the heat boiler, this is 0.1 class, ha? Ito yung gagamitin nating notation. 0.1. After the steam is extracted, we have 0.2 here. 0.2 and 0.3. And this is now 0.4. Yan. Papuntang boiler, that is 0.4. From 0.1 class, as you can see, siya yung pinaka-peak. Kasi from the boiler, kung ano yung lumabas doon, that is considered as 1. Okay? So, this is now your 0.1 here. This is the 0.1. Ibig sabihin, dito na yung nangyayari yung heat natin. Okay? So, during this process class, nagkakaroon ng isentropic expansion. So, the entropy at 0.1 is equal to entropy at 0.2. Kasi class, bumababa na yung pressure natin at 0.2. So, from higher pressure at 0.1 here, bababa na siya sa pressure at 0.2. Okay? And after that, since sabi ko nga, yung condenser natin is a heat exchanger, okay, isulat ko kung anong mga nangyayari. So, dito sa 1 and 2, dito yung turbina natin, turbine. Okay, ha? After 2 and 3, we have here. Two and 3. So, this is now the condenser. Dito, class, nangyayari yung heat rejected. Okay? Condenser, and dito yung pump. Pinapump niya papunta sa boiler. Okay. We have now 0.2. This is 0.3. And from here, this is 0.4. Okay? Anong nangyayari sa boiler natin? Automatically, heat is added. Ibang color lagay natin. Black. In the boiler class, heat is added, QA. And dito class, from process 1 to 2. Sa turbina natin, meron ditong work ng turbina, wherein that is a positive work. And we have also sa condenser, yung heat natin is rejected, QR, dito, heat added. Okay? Pag rejected, automatically, minus ka, pag heat added, positive yan. And from the work of the pump, pasensya na, may mga aso. Okay, from process 3 and 4, magkakaroon na tayo ng, naririnig nyo kasi yung video 5 ng kapitbahay namin. Okay, from point 3 to point 4, we have the work of the pump. So, this is a negative work. So, this is now the process of this is now the Rankine cycle. The TS diagram of a Rankine cycle. Yan. So, hindi pa, ganito class yung basic natin ha. Basic. Pag sinabi kong basic, yan pa lang yung pinaka basehan mo ha. So, this is now your pressure 1 ha. Based from the figure, makaka-note ka dyan. Ayan. Pressure 2. Okay, this is the pressure 2. This is the pressure 1. Ay, hindi pala ito nakikita. Okay. Ma'am, tanong, paano ma'am kung superheat yung process mo at point 2? Yes, pwede po yun mangyari. Na superheated pa rin yung value natin. So, ibig sabihin, hindi dyan sa loob ng wet mixer region, magfo-fall yung point 2 mo, kundi doon sa superheated. But take note, in process 1 to 2, okay, processes na tayo. Processes. So, i-combine na natin ha, lahat ng processes na tutunan natin. So, in process 1 to 2, ayan ha, tingnan nyo, from process 1 to 2, from the figure wherein the work of the turbine exists. Okay, this is a turbine. Anong nangyayari dyan? Yung entropy natin at point 1 is equal to entropy at point 2. Okay? Meron tayong isentropic expansion. Yan. Expansion yan. Expansion in the engine. So, yung entropy natin is constant. While from process 2 to 3, kung saan nangyayari si heat rejection and andon si condenser. Anong process siya? This is a constant pressure. Kasi class, ito, from point 3 to point 2, constant siya. Kasi ganito baga class yung figure natin pag TS. Ganito class yung TS natin. Considering this is your TS. Pag constant pressure class, automatically ganito yung notation. Pantay palagi sa wet region, but pag ganito. Okay? So this is now the pressure constant. Okay, constant pressure, nagkakaroon ng rejection of heat in the condenser. Ayan. So, we have pressure 2 is just equal to pressure 3. Yan yung, kasi constant yung pressure natin, as well as we have the heat rejection. Okay? And from process 3 to 4, balikan nyo dito sa ating TS diagram natin. TS diagram. From process 3 to 4, anong nangyayari? Si pump. Okay. May work si pump, negative. So, mag-fall siya sa pump work. Anong nangyayari? Ibig sabihin, adiabatic pumping. Pag adiabatic, yung heat natin, change in heat is 0 and yung entropy natin is constant. Okay? Yan na. Sa work ng pump. Yan baga class. S3 is equal to S4. But in solving the work of the pump, hindi tayo mag-interpolate. We make use of the equation from the H3 para makuha natin yung work of the pump. Okay? Magkakaroon tayo ng cycle analysis. Okay? So we have now the work of the pump. Got it. And from point 4 to point 1. Ano yun, class? From the figure. From point 4 to point 1. Andun si boiler. May heat addition ka. Heat addition si boiler. Okay, we have now the boiler. Okay, heat is added in the boiler. Anong nangyayari, class? We have a constant pressure, same as the process in the rejection, ha? Pero, constant pressure, addition of heat in the steam generator or the boiler. Generator, we have the, ayan, parehas din siya ng TS. So, we have the pressure 4 is just equal to pressure at point 1 kasi yung pressure nga natin is constant. Magkakaroon ng heat addition, heat added. Okay. Yan. So, this is now the processes. So, pinaghalo-halo na. From point 1 to point 2, we have entropic expansion. In point 2 to 3, we have a constant pressure or the isobaric process. But also, and heat rejection. From process 3 to 4, wherein the pump is involved, meron tayong adiabatic pumping. Siyempre, wala doon na heat. As well as yung constant yung entropy natin, S3 is equal to S4. And last but not the least, in the boiler, okay, andun kas nangyayari yung heat addition, okay, from pressure 4 to, which is equal to pressure at point 1. Okay? So we will move on to the cycle analysis. Cycle analysis. Processes pa lang yan, class. So, paano mo siya masosolve? Paano mo masosolve siya? We proceed now with the cycle analysis. Ano, class, nangyayari sa cycle analysis? Unang-una, dun sa boiler, anong nangyayari, class? We have the heat addition or the heat added, noted as QA. Okay. Draw mo ulit si boiler. Ayun na. Balikan mo dito sa schematic. We have the boiler. Point 4 and point 1 in whole. In a boiler, okay, we have yung papunta sa steam is point 1. Papunta to ka sa turbina, ha? Turbine to. And we have here the point 4 galing sa pump. Anong nangyayari sa boiler? We have heat addition, QA. Okay. Paano, ma'am, yung cycle analysis natin? Cycle analysis, class, all you need to know is all entering energy is equal to the all energy leaving the system. Okay? The entering energy is just equal to the energy that is leaving. We have out. So, tinatawag to, class, na energy balance. Okay? From our thermo 1, all energy entering in the system is just equal to the all energy leaving the system. Okay? So, we have now, what is the entering energy? Using the notation, okay. Since, class, heat addition, ang involved po dito is the enthalpy. We have the H4 and the H1. Okay. At point 1. So, what is the entering energy? Yung mga arrow ko, class, ano yung nakikita nyo dyan? So, entering, we have the heat addition plus the enthalpy at 0.4. And the leaving now is H1. So, in computing the heat addition, we can make use of the general equation of H1 minus H4. Okay? So this is now the process on how we compute the heat is added, expressed in kilojoule per kilogram. That is now the heat addition. What about the heat rejection? Or the heat rejected, the QR. Anong yung process cycle natin? QR is 2,3, 2,3, QR, and 2,3. We have the condenser. Okay, in the condenser class, draw mo ulit yung basic natin. We have now the condenser. Ayan. Okay, in a condenser class, ganito sabi ko. Ayan. So, the cooling water. So, disregard the cooling water, but in the heat rejected class, from the turbine, di ba yung turbina natin, turbine. So, this is 0.2. So, we have enthalpy at 0.2. And the leaving energy is 3. So, the enthalpy at 0.3. We have now the QR, or the rejected heat. Now, the energy balance natin, class, all entering energy is equal to the all leaving energy. Ito palagi, class, kahit di mo kailang isaulo yung formula. If you know how to balance the equation, you can use this. Okay? So, all entering, ano yung entering, class? From the arrow, it is just the enthalpy at 0.2 sa turbina natin. And the energy leaving now is the enthalpy at 0.3 and the heat rejected. Computing for the heat rejected, we have now H2 minus H3. This is always expressed in kilojoule per kilogram, but if in a given problem we have a mass, then multiply it, makukuha mo into kilojoule. Okay? How about if we have now the H2, ano naman, class? Punta tayo doon sa engine work. Engine work. Anong engine work natin? Ano yung nag-work doon? Work ng turbine. Okay, so kadalasan ng work ng turbine, balikan mo dito. Sa pinakauna, we have 0.1 and 0.2. Work of the turbine. Okay. We have the work of the turbine. Ano yung gagawin natin? Yan, i-draw mo ulit, class, yung components para makita mo kung paano siya gumagana. Ayan. So, entering, leaving, may work ng turbina. We have here H1 from the boiler. Leaving now is papuntang condenser, 0.2, H2. Okay. Paano, ma'am, dito? So, energy balance ulit, class. Nabobore na kayo kasi energy balance. Energy balance, all entering energy is just equal to the all energy leaving the system. So, entering class, yung tingnan niyo yung mga arrow ko, we have the H1 is equal to H2 plus the work. Okay, positive yung work natin. Have now the work, H1 minus H2. Expressed work of the turbine. Expressed in kilojoule per kilogram. In the work of the turbine class, pag sinabi na may change in kinetic energy, okay? Pag sinabi sa problem na may change in, kasi sa potential, alam, change in the kinetic energy, pag binigay sa atin na may change in, considering that we have a change in kinetic energy, okay, we need to compute for that. So, entering H1 plus the kinetic energy at 0.1, dadagdag lang natin siya kasi may living energy naman siya. Plus the work of the turbine. So, in computing for that, we have the work of the turbine, the H1 minus H sub 2 plus kinetic energy at 0.1 minus kinetic energy at 0.2. We can use this also, this equation, H1 minus H2 plus 1/2 mv squared. We have 1/2. Okay. Mass kasi hindi expressed in kilojoule per kilogram to. So, automatically, velocity na lang at 0.1 squared minus velocity at 0.2 squared. Okay? So, this is now expressed in kilojoule per kilogram. Okay? Pag minultiply na siya class by mass, magiging mv squared na siya. Okay? And last but not the least, energy equation and engine work. This is now the cycle and the heat addition, the heat rejection, the work of the turbine, and last but not the least, the tinatawag nating pump work. Okay. Okay, so work of the pump. Balikan mo to doon sa pinakataas. We have the pump. Okay, pump. Anong nangyayari sa pump? Entering from condenser to class. Have now the H3 and the living energy now papuntang boiler is 4. So we have the H4. Ano class nangyayari? Negative ang pump. Negative yung pump natin. So, work ng pump. Negative. So, the energy balance in ayan, matagal pala mag-ano. The entering energy is just equal to the living energy. Okay. Ano po yun, ma'am? Bakit, ma'am? Ayan. May tinatawag tayo, class, na exact pump work. Ito, class, yung exact pump work. Okay. May exact pump work tayo. Ito, class, yung exact pump work. Yung energy balance natin. Okay. So, entering is H3. Ay, wait. Para hindi kayo ma-confuse, hindi ko na in-negative to, class. Kasi hindi naman talaga siya talaga yung nag-produce. Okay? So, yung work ng pump natin, siya yung gumawa, papasok. Okay? Para hindi turuan ko na lang kayo pag nagsusolve na tayo. Okay? Kasi negative talaga yan, class. So, H3 plus the work of the pump kasi siya yung gumawa plus H4. So, this is now the pump work, the exact pump work. Exact. We have now the H4 minus the H3 in kilojoule per kilogram. Okay, class. If we have the exact pump work, kadalasan class in finding the pump work, hindi to ginagamit. Take note, hindi to ginagamit, but this one, yung approximate pump work. Bakit, ma'am? Tatanong kayo. Okay, the state of the feed water leaving the pump is that of a compressed liquid. Okay. Ibig sabihin, class, yung from condenser, yung liquid natin is considered as, yung ano natin, substance natin is considered as compressed liquid. So, compressed liquids, class, are not available. So, the properties of a compressed liquid are not easily obtained using the steam table, class. So, the exact pump work, class, is difficult to determine. Yan. Wala tayong table para sa compressed liquid. So, we have the following assumption. Okay. Ano yung mga assumption natin para makompute itong pump? Following assumptions are made to determine the approximate pump work. Okay. Paano yung pump work natin? Kasi water is practically, yan, ito yung mga notation natin. Water is practically an incompressible liquid. Incompressible liquid. Okay. So, ang gagamitin natin, class, therefore, yung specific volume sa 3, volume is just equal to the specific volume at 4. So, this is a constant volume or isometric process. Kasi incompressible yon, practically speaking. And we have also this assumption that the change in internal energy the change in internal energy is negligible. Yan. So, ibig sabihin yung internal energy natin at 0.4 is just equal to 0.3. Kasi magiging 0 yun. Negligible. So, ano yung gagawin natin in solving this problem? So, theoretically speaking, in the pump work, okay, we have the feed water. Okay? So, yung papasok, class, now, energy equation ulit, we have now the energy balance. The entering is equal to leaving. Ano, class, yung entering natin sa condenser natin? That is a feed water. Okay? So, that is the feed water leaving the pump. Okay? Leaving the pump and entering the pump. Okay. Yung assumption natin, entering the internal energy plus the work at that point. At 0.3, so from the condenser, plus yung work talaga ng pump natin. Kasi negligible, incompressible yung liquid natin. Okay. We also take note of this notation, the U4 and the work sa feed water, leaving the pump. So, papuntang boiler. Papuntang boiler or F4. You can use this, the work for. Okay? Papuntang boiler. So, leaving and entering. So, alam naman natin na negligible yung change in internal energy. So, matitira, class, sa atin is this one. we have the work of the pump. The work doon sa leaving of the feed water. Yan, class ha. Yung feed water natin, the state of feed water leaving the pump is of a compressed liquid. Is that of a compressed liquid? Wala naman sa steam table natin ng compressed liquid. So, the properties are not easily obtained. So, kukunin natin tong assumption na to. So, yung feed water natin, galing sa condenser minus sa, sa boiler, WF4, minus sa feed water natin, galing condenser. Okay? Ma'am, ano po yung gagawin natin dito? Okay, so the work of the pump, actually now we have using the ISO pinakauna natin, the change in, since specific volume class isometric, we can use the equation, the produced work at that point. So, babalikan natin sa processes ha, sa processes balikan nyo class, that the pressure at point 4, this is just equal to the pressure at point 4 and the specific volume at 4 minus the pressure at point 3 times the specific volume of 3. Okay. Noting that the specific volume at 3 is just equal to 4. So, yung work ng pump natin, kadalasan sinusolve as the specific volume at 4 times the pressure at 4 minus the pressure at 3. Okay. So, ito po yung equation natin in finding the work of the pump. Okay. Ano yung unit mo? Cubic meter per kilogram. Yung pressure mo kadalasan is in megapascal, meganewton meter squared. You converted the mega into kilo. 1 megapascal or 1 meganewton is equal to 1,000 kilonewton. So, matitira sa'yo is kilonewton meter. So, cancel din to. So, matitirang isa. Ang matitira sa'yo is kilonewton meter per kilogram. So, we have now kilojoule per kilogram. Okay? So, we have now the work of the pump in kilojoule per kilogram. Okay. So, this is now the approximate pump work in solving the problem. And last but not the least, we have now the net cycle work. We have the net cycle work. So, you compute for this using the work of the turbine minus the work of the pump. Okay. So, this is now the gross work minus the pump work. So, nasa-solve mo to class using this. Yan. Alam naman natin that the work of the turbine is H1 minus H2 minus the work ng pump. Okay. So, this is now your work of the net cycle work. Okay? Mahaba na class. This is just the very first, the very basic power cycle. Letter E pa lang tayo. Pag sa reheat class, dalawa ng turbine ang isusolve nyo. Okay? So, we can also determine class the cycle para makuha natin yung thermal efficiency natin. Okay? Letter F, last but not the least, the thermal efficiency. thermal efficiency. Ayun, ganito natin. Yan. Thermal efficiency. Okay, yung efficiency natin, class, is equal to the work net over the heat added. So, yung work net natin, H1, H2 minus work of the pump. Ano yung heat added natin? That is also equal to the heat added, H1 minus H4. Tama ba? Heat added, QA. Masaling QA. Yeah, tama. H1 minus H4. H1 minus H4. Or some of the books, this is H1 minus H2. Over H1 minus H3 minus work of the pump. Ayan. Para malito kayo. Pero pag dinerive nyo to, class, ginamit nyo dito yung exact pump work. Okay? So, this is now the thermal efficiency. Okay? So, how about the steam rate? Paano tayo nag-compute sa steam rate, class? Okay? E, F, G. Ihatag ko na lahat para before tayo mag-solve ng isa. Madali lang muna yung solve natin. Yung steam rate natin in M, or yung mass na sinasabi ko, that is the mass of steam used to perform a unit work or the mass flow, the mass flow rate of steam consumed to produce a unit of work. Produce a unit of power. Yan. So, paano mag-compute test ng power? Okay. So, yung power natin, kadalasan is the power output. So, kilowatts. Ano class yung kilowatts? That is kilojoule per seconds. Baka hindi nyo naman alam. The work done. So, we have now the work. Maingay na class. So, we have now the work done by a kilogram of steam. We have kilojoule per kilogram. And yung mass natin, that is the steam rate. The kilogram. Wait. Nangyari. Okay. The kilogram per kilowatt hour. Ayan. Yan yung kadalasan, class. So, in computing the steam rate, class, mag-divide lang naman kayo. We have the mass flow rate divided by the power output. Okay? So, yung mass flow rate natin, that is in kilogram per hour. And the power is in kilowatt. Kaya nangyayari kilogram yung steam rate natin. Okay? Ang power naman, class, automatically power. Computing for the power, the mass flow rate, kadalasan expressed in kilogram per hour. Multiply mo lang by the work. Okay, the work in kilojoule per kilogram. So, pag nag-convert na lang kayo, klase ko, convert nyo siya from 1 hour to seconds. Okay, 3,000 seconds. Okay, so this is now your formula in power. Pag kinumbide mo na to, class, in using the steam rate, yung M natin, the power, okay, yung steam rate natin, lagyan ko dito para hindi kayo Ay, wag na. Sa mass flow rate pala yan. We have now the steam rate. Equal na to sa mass flow rate natin. You substitute na lang, class, in kilogram per hour. So, we have the mass flow rate. So, maka-cancel to, class, yung mass flow rate natin. Tama ba? Pero i-multiply mo muna siya sa work done in kilowatt. Okay, kilowatt na kasi may 3,600 ka na dito. Okay, so that is now your steam rate. So, mangyayari, class, yung steam rate mo na lang is ganito. 3,600 divided by the work. This is the work, ha? So, kilogram per kilowatt hour. This is now your steam rate. Okay? Okay. Yan. Alam na natin yung basic cycle analysis ng Rankine Cycle. We just, pasadaan ko lang kayo, class, ng isang example para maintindihan natin ang, mahaba-haba ito, class. Madami tayong kukunin. Okay? So, paano, class, yung gagawin natin when it comes to solving the Rankine cycle? So, wala pa naman yung actual cycle. Mas maganda yung example dun sa libro. Okay? So, for the meantime, ito na muna yung pag-aralan nyo. Okay, class? The different processes in the Rankine cycle and the cycle analysis of the given problem. Okay, ito muna yung tatandaan nyo, the TS and the schematic diagram. You practice solving ito, class, ha? Ito lang, pag ito lang yung alam mo, kaya mong ma-derive yung formula natin sa cycle analysis. All energy entering and leaving the system. Okay? Yan. So, pag-aralan kung on how does the different equation was derived. Class. And using the TS diagram, without looking at the schematic diagram, you can draw the schematic diagram by the analysis. Oh, ito, from point 4 to point 1 boiler yan. So, it undergo the process of steam expansion. And from point 1 to point 2, the turbine. Okay, the turbine is, the work of the turbine is added. So, meron ka na dyan na turbina. Okay? From process 1 to 2, that is an isentropic expansion. Makikita nyo yan, 1 to 2. Constant entropy siya. So, if kukunin mo yon when solving a problem, given palagi yung pressure ni boiler. Okay? So, we have the pressure of the boiler. After that, you compute for that. We have now here the given sa atin yung pressure 1. So, pupunta ka doon kay anong table, class? Pag sa point 1, that is a superheated vapor. So, table 3 ka, makukuha mo dun si entropy mo. Using the entropy at point 1, at superheated state, that is equal to entropy at point 2. So, makukuha mo yon. Okay? Given palagi yung pressure 1 and pressure 2. Yung pressure 1 at point 1 is equal to pressure 4. Yung pressure 2 is equal to pressure 3. Yan yung mga salient points natin na dapat malaman. Okay? Bakit? Kasi when computing for the work of the pump, you have to go to the pressure at point 2 but using the saturated pressure, saturation pressure. Kasi ang kukunin mo lang doon is the specific volume at saturated liquid. Okay, automatically makukuha mo yan using the steam table. Okay, so mahirap to i-digest muna, class. So I will just leave it to the very first discussion of the Rankine cycle. So you have this, the boiler to the pump, the boiler, turbine, condenser, and the pump. Okay? So may question ba class dito sa Rankine cycle? So read the book, the vapor cycles that I have uploaded on the very first dun class sa Google Classroom natin. Okay? Para mas maintindihan nyo kung ano yung process ni Rankine cycle. Okay? So, you have sa turbina, work. Sa condenser, heat rejection. Sa pump, negative work of a pump. Sa boiler, heat addition. Okay? So, wala sa TS diagram. Yan. Pwedeng mangyari from point 1 to point 2, yung sa condenser natin, class, superheated pa siya. Okay? So, yun lang class yung kadalasan. Yan, para mas. So, ito class yung kadalasan na sinosolve sa TS diagram. You know how to draw the schematic diagram of the turbine. So, ito yung kadalasan na kaya i-check mo. So, ito yung sinasabi ko class. Without looking at the schematic diagram, alam mo na dapat na, yan. Ganyan yan, class. Take note. Ito, class, oh. Dito nangyayari si pressure 4 equals sa pressure 1. Mga ganyan, class, yung iti-train nyo. Pressure 2 equals sa pressure 3. Considering that ang palagi yung starting point, hindi naman palagi, but considering na yung point 3 natin sa pump is always at the saturated liquid line. Okay? Papunta, straight yan sa pump, ay sa boiler. So, from point 4 to point 1, yan. Ayan, straight line and papunta doon, superheated vapor. And ito yung sinasabi ko, kadalasan na value natin sa point 2 is also falls at the superheated region. Yan. Kaya may paganon pa rin, may kanto yan class in straight line. Yan. Pwede itong mangyari class. Okay? Ito yung ideal. Pag actual class, may ganito. 2' ka na dyan. And dito, 4'. Ayan. So, this is the different orientation of the schematic diagram of the Rankine cycle. Okay? So, if you don't have any question, then may question ba, class? Mahirap. Tapos, aalamin mo lang dito, boiler to. Sa boiler, anong nangyayari? Heat addition. From point 1 to point 2, this is turbine. Turbine to. Anong nangyayari dyan? Work ng turbine positive. From point 2 to point 3, anong nangyayari? We had heat rejection. So, this is in the condenser. And from point 3 to point 4, nangyayari dyan, work ng pump. And that's negative. Yan. So, kahit sa TS diagram, kaya mong i-draw yung schematic. Yan. Okay? I mean, of the Rankine cycle. Okay? So, for now, yun muna, class, kasi I will give example on the Rankine cycle next week. Okay? Question? May nakikinig pa ba? Yes or no? Yes or no? Okay. Yes po. Apo. Okay. So, dapat madraw nyo yung schematic diagram. Yung TS diagram, depending upon the given situation. And yung TS diagram natin. Okay, class? Opo. So thank you, class, for today's presentation. Lesson. Okay, so that is the very first class, is ang kukunin na natin sa steam table, 4 na state points. So kung dati sa processes, we only have 2 state points. Now we have 4. Okay? So dapat bilis-bilisan nyo maghanap sa steam table. Double check. Okay? If you don't have any question, then I can stop sharing. Okay, can I have everyone to open their camera? Ayan, layo ng laptop ko. Nire-renta ako ngayon, class. Wala